So we're today going to continue our discussion on operating systems and how we interact with the real world in both user mode and kernel mode. So let's just remind ourselves why we have an operating system. What we designed was a beta that can run a single program. It runs one instruction every cycle. And then we busily hooked it up to a world of gadgets, keyboards and network interfaces and things like that. Plus we have issues about the how the user mode programs, the different application programs that you're running, interact with each other and interact with all of these hardware devices, disks and memories and things like that. So we created a virtual machine for each separate process, which gives each process the illusion that it lives in its own address space. It has addresses starting at 0 and can ask the operating system to allocate chunks of address space and memory for various purposes. What we've done is we went ahead and virtualized the access to the keyboard. So there's a notion of every process has its own virtual keyboard. And we're sort of stuck now with the problem of designing some code to take a real keyboard and sort of use and multiplex it among all the different customers. And the way you do that now in your system is you end up clicking on which window you want to type into, and now your characters will go to the process that is generating the display for that window. So the piece of the software that does all the intermediation between the actual hardware and all these different virtual machines we call the operating system. And in fact, there's a part of that operating system we call the kernel, which is always resident. In other words, it lives in memory. And that is a part of the operating system that we have to, where we, down here at the bottom, where we have the things that need to interact with the hardware and with your programs. So there's always a user mode program running, and you might have an illegal instruction. You might try to divide by 0 at the hardware level, or you may access a part of your virtual address space which is not resident in memory, and we'll have to deal with the page faults. Or the network interface may have some interrupt that needs to be dealt with. So part of the kernel is always present, so it can deal with these things that could happen at any time. And other parts of the kernel may come and go, sort of like parts of an application process may come and go. So the kernel may, in fact, page in different parts of the operating system to deal with, obscure file system APIs and things like that. So, but if the interface between the operating system and the applications is this virtual machine, and that's our sort of boundary. You program as if you're running on the virtual machine, and you access the permanent storage in the file system as if it was organized as a bunch of hierarchical folders with symbolic names. And it's really the operating system whose job it is to translate, please open, foo.txt and give me character 3, turning into an actual access to disk and dealing with telling the disk hardware, what sector to seek to and what to read back, and then selecting the right bytes, and after checking that you have permissions to access those bytes, so forth and so on. Okay, so we have the virtual world that the applications run in, and we have the hardware that we've talked about designing up to now, and the operating system is the glue layer that glues those two worlds together.